Welcome to DevOps Toolkit, the channel where we trash graphical user interfaces that are too complicated to set up and maintain. Today we are going to explore Backstage from newbie perspective. We'll see what it is, what its main components are, and how to set it up. We'll go from nothing to an operational portal in development mode. Unlike other similar tools that often require us to simply configure and run them, with Backstage, we have to get the source code, develop or configure what we need, and run it on our laptop to see the result. Later on, once we're happy with what we did, we might explore how to package it all up, run it in production, and do whatever else needs to be done. So, let's start from the beginning. Backstage is open source framework for building developer portals. It's what we put on top of our system to enable people to control it and observe it using graphical user interface. It's a front end for your backend, which can be, well, anything. It's a UI on top of whatever we use to manage our applications and our infrastructure. It's a bridge to Git and pull requests. It's a window into CI/CD workflows. You got the point, right? It's a user interface that potentially integrates everything we need to manage our systems. I will not go into details of what it is, but simply say that it is an internal portal into everything else. It's the entry point for those who like clicking with their mouse instead of writing commands in terminals. It's for those who do not know how to use the tools required to manage the system. It's for those who don't like writing code. It's a glorified catalog with links that lead elsewhere. It's for those who despise monochromatic terminals and crave for a more colorful world. Or at least those are some of the things it's trying to be, and we are yet to discover whether that's really the case. Anyways, what matters is that there are 4 important things we should know about Backstage. First, it is not a typical product we configure and run. It's source code that we put on our laptop and develop whatever we need. Next, it can be extended by plugins, and we can choose to use those developed by others or write our own. Then it has components that represent some logical entities like applications and infrastructure. And finally, it has templates that can be used to create dynamic forms with fields, drop-down lists, and other elements that can be filled up by people who do not like writing YAML or JSON. The data from those forms can be used to perform some actions. So, it's source code that can be extended by plugins and that uses components to represent something and templates to create something else. There's your definition. Of course, there's much more to it than that, but mastering those 4 concepts should give you the necessary base for everything else. Those are the things we will explore today, so buckle up. We are about to get Backstage source code and figure out how to run it on our laptops. Unlike many other projects, we cannot simply run Backstage. There are no official container images we could use to run it with Docker. There is no official Helm chart we could use to install it in Kubernetes. There are none of the things we normally get when we want to use a third-party application, at least not provided by the Backstage project. We are not supposed to simply run it. We are supposed to get the source code and use it as the base on top of which we will build what we need. Whether that's a good or a bad thing is something I'll avoid discussing in this moment, in this video, partly because I already did that at the beginning of the video over there. So go and check it out. Now, we can get Backstage source code by cloning project's repository or through npx. Today we'll use the latter, so let's execute npx to create a new Backstage app. At the very start, you will be asked for the name of the application. If you're following along, keep the default name Backstage, since the rest of the instructions will assume that's what you did. From here on, all we need is patience. It might take a while until Backstage downloads half of the internet required to run it. So, let's fast forward. Okay, now we can enter the newly created directory that contains the source code and take a look at appconfig YAML. That is the main configuration file from where we can control the main aspects of Backstage. Now, to be clear, that's not the only configuration we might need to use, and not all configurations are YAML. More often than not, we might need to edit TypeScript files as well. Nevertheless, appconfig YAML is arguably the most important one, making it the first one you should get familiar with. That's where we define base URL of the application, which database we would like to use, what the integrations are, what the locations for the catalog components are, and so on and so forth. Most of those should be self-explanatory, and we'll explore it in a bit more depth later when we replace it with our own. For now, the only observation I will make is that parts of it are not even valid YAML entries. For example, the Kubernetes key does not have a value. That's not allowed in YAML. Yet Backstage tends to be happy with it, so I will avoid the rant that puts Backstage authors to shame. So, for now, we'll keep that configuration as is, since the first objective is to simply run Backstage without any modifications. Modifications will come later. To have a bit greater visibility into what's going on, we'll set the environment variable log level to debug and node options to avoid an issue using templates when running with Node.js 20 or later. By the way, Backstage is full of do this if you're not using an ancient version of something, so the best strategy is to simply do workarounds without questioning them. Okay, now we can run Backstage in the development mode by executing yarn dev. But before we proceed, let me say that if you're not familiar with Node.js and TypeScript, you have to be prepared for a lot, and I repeat, a lot of pain. Backstage is a project that assumes that those using it are Node ninjas, and if they are, they're supposed to experience only a moderate level of pain. So you're either not skilled in Node.js and TypeScript and you will be in a lot of pain, or you are and you will be still in pain, but in more modest quantity. Pain is unavoidable with Backstage, so you've been warned. Anyways, the yarn dev command run Backstage in development mode and open the home screen in the default browser. Over there, we can see an example component that represents a fictional website. If we click on it, we can see all the information about that website. There's the overview with the about section with mostly static information, the relations with two other components, potentially useful links, and a few other widgets. There is also the CI/CD section where we could have information from workflows, dependencies, and docs or documentation. We will explore components later. For now, let's take a quick look at what else we got out of the box. If you go back to the home screen, we can click the Create button, which leads us to the Create a New Component screen. That's where templates are located. They are essentially a list of forms that can be filled with data that can be transformed into some actions. There is only one template for now, so let's click on the Choose button. That's the pretty form where we can put some data like the name of the component we would probably like to create and follow the on-screen instructions. We'll explore templates in more depth later. For now, what matters is that we saw most of what Backstage has to offer by default. If you need more, and we almost certainly do, we need to add some plugins, write some components, and define some templates ourselves. We'll do all of that soon. For now, let's close the browser and stop the process by pressing Ctrl+C. Backstage alone does not do much. Most of what we can do or see in it is done through plugins. From that perspective, it is very similar to, let's say, Jenkins. Some of the plugins are baked into Backstage and we already had a glimpse of them. For example, the example template we saw is powered with the Scaffolder plugin. The documentation widget we saw in the example component is using the TechDocs plugin. However, more often than not, those baked-in plugins are often not enough. Depending on what we want to accomplish, we might need to add additional plugins developed by others, and if that's not enough, we might even need to develop our own. So let's say that we would like templates to be able to perform some actions in GitHub. To be more precise, let's say that we would like to have a template that pushes manifests to a repository. We could develop something like that ourselves, but since that is such a common task, there is already a plugin that does just that. All we have to do is install it and configure it. So let's do just that by executing yarn to install a plugin inside the packages backend directory. The plugin itself was developed by the Backstage community, so the address of the plugin is @backstage and the name is plugin scaffolder backend module GitHub. It might take a while until the plugin is installed. It won't take too long, since unlike Backstage itself that downloads half the internet, plugins tend to be much smaller, yet not small enough. Now, you might think that installing a plugin is all it takes, but that is not the case. We also need to tell Backstage to use it by opening packages backend source index ts and adding import of plugin scaffolder backend module GitHub. Let's add one more plugin just for good taste. For example, we might want to include the GitHub plugin that will extend the capabilities of the catalog so that we can see some information from a repo associated with data that represent an application or something similar. That was a mouthful, but we're going to install it anyways. The process is the same. We should execute yarn in the packages backend directory to add the plugin catalog backend module GitHub plugin. Just as before, adding the plugin is not enough, so we must edit the packages backend source index file to add the plugin itself. Now that we added two plugins, we can run Backstage in development mode again. So there we go. So far, we haven't done anything that changes the behavior of Backstage. We still need to figure out how to use those plugins. Right now, they are lazy bastards that are just sitting there doing nothing. We'll make them productive soon. For now, let's open /create/actions page that contains the list of all the actions we could perform through plugins in that Backstage instance. That is a not easy to find yet very helpful page that lists all the actions we can perform. For example, we can see that publish GitHub pull request is there, and we can see which fields can be used as input and which will be output. That action is not available in Backstage out of the box, but was added when we installed the plugin. We'll use it when we define our first template. That's the very quick run through plugins. So let's stop the Backstage process by pressing Ctrl+C and explore the next subject, which is about components and templates. In Backstage, component is something. It's hard to define what that something is, since it can be anything. It could be a front-end or a back-end application. It could be a part of an application. It could be a piece of infrastructure or a database or a cluster or a serverless application or anything else. It's up to us to define what we want to present as a Backstage component. In order to spice things up by moving out of the typical this is a website type of component, I defined one that represents a Kubernetes cluster managed by Crossplane. So let's take a look at it. You will notice the definitions of Backstage components are similar to Kubernetes definitions, yet sufficiently different to confuse everyone. Just as in Kubernetes, there are the API version kind and metadata fields with probably self-explanatory entries like the name, title, and description. The annotations can be anything we want, but some plugins will require specific entries like, for example, github.com/project slug that tells the GitHub plugin how to find the associated repository. Then there are tags and links that, as we'll see later, contain static information that will be shown in Backstage. Finally, the spec entries are, at least for now, largely informative and not worth our attention. So far, the component resource contains mostly static information and does not serve any specific purpose, at least not if we do not start feeding it runtime information. A more interesting type of Backstage resource is the template. So let's take a look at one I prepared. That's a big one, isn't it? It contains two main sections inside the spec. There are parameters which essentially instruct Backstage how to construct a form users can use to fill in some data. Further on, there are steps which define actions that should be performed when someone submits data from that form. The parameters are more or less based on the same format as Kubernetes custom resource definitions or CRDs, and I would be very, very grateful if Backstage would be able to read them. As it is now, those of us creating CRDs need to do the same work twice, at least twice, and essentially define the same data in two similar yet sufficiently different formats. Now, to be clear, I hate spending my time doing redundant tasks. Yet, that's what we have, so that's what we're going with. Anyways, the title defines a screen. So once we add that template to Backstage, there will be a screen called Service Selector, another one called Service Definition, and so on and so forth. Each of those pages can have any number of properties, or to be more precise, fields. So in this case, there will be a field called name. That field will accept any string, and once that page is opened, it will be in focus. Then there is provider, which has 3 enum values. Unlike the name, which will become a field, the provider will be a drop-down list with AWS, Azure, and Google as values, with AWS being the default one. I will not go through the rest of the properties since they all follow more or less the same pattern. Further down, there is a list of required fields, and then it is all repeated for the next page. Once we have all the pages and forms and fields defined, we have the steps. Think of them as actions that are performed every time someone submits data based on those forms. In this particular case, the first step will output a log message if the bug is enabled. That message, like almost any other value in the steps, is parameterized, so the message will contain the name taken from the parameters. I put that first step mostly to warm us up for the real deal that comes next. The fetch template action will take templates from the manifest templates directory and convert them into a manifest. To be more precise, it will pass to templates in that directory values with keys, name, namespace, and others, and add values from parameters, which essentially is data from the form we defined earlier. This part is yet another thing I really dislike about Backstage, since it feels like redundant work. I have a parameter name that happens to be the same as a parameter name in the CRD, which should become a value called name, so that name in a template can finally become something meaningful. Now, if you didn't understand that sentence, that's because it's madness. And I do admit that there are cases when all that might be necessary, but more often than not, it's all about defining the same thing in an infinite number of places. Whomever said that Kubernetes is too verbose never experienced Backstage, because after Backstage, Kubernetes is simple and definitely not verbose. The third step will rename the output of the manifest generated through the template as a semi-unique name based on the name parameter. From there on, the fourth step will create a pull request. As a result of all those steps, when someone submits data through a form, the end result should be a pull request to a repo with a new manifest based on a template. From there on, someone could approve that pull request by merging it to a mainline, and assuming that Argo CD or Flux are set up, the resource defined in that manifest should be synced into the cluster. From there on, in this specific case, crossplane running in that cluster, which we call control plane, would create a new Kubernetes cluster based on user input, right? At least that's the goal of all this, even though we are exploring only Backstage today. The last part of the steps is the output, which will provide a link to the URL of the newly created pull request. Now, you might think that we are done, but we are not. We still need the template that one of the steps will use to generate the manifest. As I already mentioned, Backstage is very verbose, and we often need to define the same thing over and 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 over again. Anyways, here's the template that will result in the manifest that will be pushed to a repo. That's very similar to a template in, let's say, a Helm chart. The main difference being that there are dollar signs in front of opening double curly braces, right? Anyways, very similar. Also, did I mention that it's confusing that there is a Backstage template that needs other templates to generate manifests? If I haven't, now I did. It's silly, but that's what it is. Okay, so you might think that now we are finally done, but I will have to disappoint you again. We still need to make a few changes to the app-config YAML. To simplify things, I already created one that we can take a look at and copy to the Backstage root directory. There are only a few important differences when compared with the original config file, apart from removing the comments. I added template in the allow entry in the rules section. That will allow us to import the template we explored earlier instead of going to the web UI and clicky buttons to accomplish the same. Now, we could import components and templates from the local file system, like in the examples inside the locations section, but that's just silly, except maybe during development. A much better way to import those is to let Backstage discover them from one or more Git repository. That's why I added the providers section. Over there, we are specifying that we would like to use GitHub to discover components and templates. That's one of the things enabled through the GitHub plugin we installed earlier. Over there, we are specifying that the organization is whatever the value of the GitHub user variable is, that it should look for a file catalog info in the root of the repo, that it should look only in the main branch, and that the repository is Backstage demo. A better approach would be to set repository value as asterisk so that all repos are scanned. But I did not want to create chaos this early while we are still learning how it works, right? So we are importing stuff from one repo and you should probably import from all or some. Now, the same is repeated in the second entry that will fetch files named Backstage Template YAML. In this specific case, I have a naming convention that components are in files called catalog info and templates in Backstage template. Yet Backstage does not care what is what. For Backstage, they are all variations of a catalog and it will import any type specified in the allow entry of the catalog rules. Okay, now we are finally almost done. All that's left is to copy the appconfig YAML file that we explored into the current directory where Backstage resides and run it. When Backstage with our modifications opens, it shows the same information as if we did not do anything. That's to be expected since it might take a few moments for it to visit the Git repo and discover the component and the template we have in there. So let's wait for a while and refresh the screen. There we go. A new component, Crossplane Kubernetes, auto-magically appeared. Backstage pulled it from the repo. If we specified all repositories within the organization and we had catalog info YAML in others, we would see them all in Backstage. If we select Crossplane Kubernetes component, we are redirected to the details page with all the information currently available. There's not much at the moment and we might explore ways to feed it runtime information in some other video. What matters for now is that whichever information is specified in the discovered catalog info YAML file is available here. On top of that, we could, but not in this video, add additional plugins or configure those that are already in Backstage to fetch more information. We could, for example, connect it to GitHub Actions so that all the workflow runs from that repository are visible here as well. Similarly, if that component represents some Kubernetes resources, we could use one of the Kubernetes plugins to show it here as well. All those are outside of the scope of this video. Now, please let me know in the comments of the video if you would like to see more, but not today. Now, if you go back to the home screen and click the Create button, we can see that a new template, the one we explored earlier, was added. If you choose Crossplane Kubernetes, we are presented with the screens and the forms we defined in the template. Okay, now, let's imagine that we are a developer who would like to create a new Kubernetes cluster. All we would have to do is fill in the fields in the first screen. When finished, that person would click the next button and fill in more fields. Pressing the next button again would redirect that person to the third screen where they would be able to select which applications should be pre-installed in that cluster. Clicking the next button one more time would present them with the review screen. Finally, once they confirm that everything looks okay, the steps we specified in the template would be executed. A few moments later, they would see the pull request link that would lead them to the pull request with the new manifest that defines the cluster based on their input. Rejoice! The rest is not directly related to Backstage, but a typical workflow any developer is familiar with. Review the files that were changed and, if everything seems okay, merge the PR into the main line. And there we go. That's it. We transformed developer experience. Instead of having to write YAML, which in my humble opinion is not that difficult, people can choose to fill in custom-made forms in Backstage, let it generate the desired manifest based on data from those forms, and create a pull request. Now, to be on the safe side, let's confirm that's what really happened. We'll go back to the root of the demo repository and pull the latest changes. We can see that a new manifest was added to the repository and we can take a look at it. We can see that the manifest is based on the input we made in Backstage. So, mission accomplished. At least for now. We saw how to set up Backstage, what its main features are, how to extend its capabilities through plugins, how to create our own components and templates, how to instruct it to fetch them from Git repositories, and a few other things. So, congratulations! You are now one step closer towards becoming a Backstage ninja. Nevertheless, there is still much more to figure out. For example, we should see how to package Backstage and how to run it in production. We should probably see how we can connect it with Argo CD or Flux so that manifests it creates are synchronized into the control plane cluster. We should probably try to figure out how to feed it with runtime information like logs, events, and statuses. In any case, this video was only the beginning, and the rest depends on your interest. So, here's the question. Was this useful? Would you like me to go further with Backstage? What would you like to see next? Please let me know in the comments. Thank you for watching. See you in the next one. Cheers.